let's pick up on number 4. If you recall, we had this formula for the derivative of the inverse that we learned yesterday. It's up at the top of that page. And I know if you look at number 4 in her notes, she uses like an alternate method to try and do this one. And I decided that it's not worth it. So we're just going to, I feel like we still need practice on the method we were taught, right?
Yeah.
And so the idea that if you go up to the top of the page, they messed with my size. Let's see here. No, maybe they just messed with that. There we go. Okay. Now my big Q is just being uncooperative. So the formula for the derivative of the inverse, if you recall, is 1 divided by, what is it, f prime of f inverse, or do I have that backwards? My brain's got to catch up here. Okay, so there's the formula that we were talking about that we used. Okay, now they ask us, let G be the inverse of f. That is the common, piece there. Let G be the inverse of f. That's just saying that G is equal to f inverse. Okay. Calculate G prime of negative 9 based on the function f of x equals 4x cubed plus 5x. Okay. So, with this in mind, that means G prime this is also the same thing as saying f inverse of x, right? Of negative 9. But they're calling it G prime of negative 9. Okay? So keep in mind, I guess maybe I should rewrite this formula also. This could be written as, well, I won't. So if I'm filling this in here, my formula is going to be 1 over f prime of f inverse of x, except what are we calling f inverse in this point? G of x. Okay, that's essentially what, not x though. What am I saying? Negative 9. I'll get myself straightened out here. So, first thing we've got to do is to find G of negative 9. Okay. Keep in mind, okay, I always have to straighten this out in my head, sorry. Nope. F of something equaling negative 9 means you're finding G of negative 9 equaling something. Does that make sense? Because f and g are what? Inverses, right? So that means the inverse of oh gosh, sorry, I'll get there, guys, I promise. The input on the inverse is equal to the output of the original function, yes?
Yeah.
Okay, so we're trying to find this value right here. So in order to do that, I'm going to go with this first piece. That f of something equals negative 9. What is f? F is 4x cubed plus 5x equals negative 9. And I think this might be part of the reason she did an alternate method here. I'll agree. There's not a good solving technique. But just look at it. Stare at it. Can you come up with what x could be? What x will make this equation true of 4x cubed plus 5x equals negative 9?
No. Right? No.
Yeah.
1.
It's 1. I don't know if it's negative or positive.
Wait. -1.
Well, we need it to get to be -9.
-1.
So 4 times -1 cubed plus 5 times -1, right? -1 cubed is -1. -4 plus -5, that is -9, yes. But do you agree that can be done by inspection? Okay, so what we know here is that we could use x equals -1, and as I said, there wasn't any actual solving. What we call that doing that by inspection. In other words, you just kind of look at it and you're like, oh, okay, yeah, I can see -1 makes sense. Okay, so what we know right now is that what? We rewrite this, f of -1 equals -9, yes? If f of -1 equals -9, then what do we know? G of -9 equals -1. And what did we need in our formula? G of -9. Do we know that?
Yes.
We do. So I can rewrite this as 1 over f prime of g of -9 is -1. Now what? How am I going to do f prime of -1? Okay, so we are told that f is 4x cubed plus 5x. F prime then is what?
12x squared plus 5.
12x squared plus 5? And so then I need to know f prime of -1. Can I do the math there? Twelve times -1 squared plus 5 becomes 17. So we have an answer of 1/17. Okay. That's your basic process. Okay. Basic as in it's going to vary from time to time. Okay. We did this a little bit yesterday. We had a chart to fill in, right? We've done some others. There was one where they told us the derivative. We got to the end and f prime of whatever we needed was given. So, you know, you just have to tweak it each time to match whatever your problem is, okay? Okay, example 5. Okay, notice the fun little calculator symbol, right?
Oh, yeah, Birdie.
Now I'm not saying you get to use a calculator on this test yet. I don't know. That would be next week, so I probably need to start thinking about next week's test. I just haven't. There are questions where you'll need to use a calculator to find the approximations accurate to 3 decimal places, and here's an example. Okay, notice, why does it say 3 decimal places? Because that's the AP rule. Okay, AP rule is they are looking for 3 decimal places. Whether that 3 decimal places is truncating, where truncating is where you just chop off after the 3rd decimal, or proper rounding. Okay, so keep that in mind when they say 3 decimal places. It could be to truncate, or it could be proper rounding. Now, with that in mind, you don't want to round early on in a problem, though. Okay, so you want to work with the decimal places, and our calculators allow us to do that easily. We want to work with all the decimal places, and then as we get towards the end, then we will round our final answer. Okay, so example 5 here. If f of x is this equation, they want us to find f inverse prime at 3, accurate to 3 decimal places. Okay, It kind of talks about some steps here. Solving f of x equals 3. This will give us the value we need. Last time we could easily do it by inspection. Last time the value we needed was a nice neat number, right? Nice neat -1. This time it's not easy to do it by inspection, and it's not a nice neat number. Okay, so I'll follow their steps, which really it's the same steps that we would have done anyways, but okay. So solve f of x equals 3. Because here's the deal, remember, right? If we're trying to find f inverse of 3, so here's the reminder, I guess. They want us to find f inverse of 3. Well, wait. Back that up. That's prime, isn't it? Okay. Starting off, we'll just go with how they, f of x equals 3. So f of x, which is what? The 4x to the 7th minus x squared plus x minus 5 equals 3. Okay. Yeah. We can try by inspection all we want, but it's a waste of time. There's not going to be something neat. So we need to find that value on the calculator. Options of how we can find that value on the calculator.
Graph it.
Could we graph it?
Yeah.
Most definitely.
Nice.
Do we remember how to graph?
Yeah. Oh my gosh, I can't get it. Oh, I got it. What? Wow.
Helps if I turn on.
There he is.
Now, I guess the question is, what are you graphing? I didn't think they asked that question. So there's a couple different ways I could think to do this, actually. Are you graphing that as an equation?
Yeah.
Okay. So, and again, there's another option here that I could take you, but, okay, now, what do we need to know?
When it equals 3.
When it equals 3. Now, what are options to figure out when it equals 3?
Can we just type in 3?
You can't because 3 is a y value. I can type in x values,
Well, I did that.
but I can't because it's a y value. Here's my suggestion. I'm going to go back into my equations and make another equation, y equals 3.
Oh.
And what are we going to be looking for?
Where they touch?
Where they intersect. Now, up in your menu, your second calc menu, there's value, 0, min, max, and there's intersect. I don't know that we've used it a lot, but there's intersect. It's asking, what's your first curve? Well, for me, it's the blue one. I can just hit enter. What's my second curve? It's the red one. I can hit enter. For a guess, only really matters if there's multiple intersection points. So really just move to the intersection point. 1.1063959. Okay. Now, I'm going to keep that whole thing right now. I'm going to keep it all for right now. I'm trying to remember. Now, one thing, Gosh, I should have tried this ahead of time. I didn't think about it. One option is you can store this in the calculator. The other option is, okay, so right there, we just found that intersection point. That x value should be stored in your calculator for x right now. Until you find something else for x, that should be stored there. But I have store value question mark on here because I don't know that I know how to store a value on here. Okay, so I'm just going to leave it as that. Okay, so what we know right now is that what? F of 1.106, I'm just going to put dot, 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 equals 3, yes? So if that's the case, what else do we know? If f of 1.106 equals 3, then what about f inverse? F inverse of 3 equals that 1.106 number, okay? Okay, so that's what we get out of there. Now, step 2. It says to differentiate f of x. Okay, this is easy. Remember the easy derivatives? What's f prime of x?
What?
F of x is this up here.
Oh, I didn't understand the question.
Differentiate means take the derivative.
Yes.
Trust me, I could tell by the abrupt silence of like, I just lost them somehow.
28x to the 6.
Okay, I like this.
Minus 2x plus 1.
Okay, are we good?
Yeah. Yeah.
Maybe. That took a moment there. Okay, differentiate f of x, which we did. Okay. I have in my notes. Okay, so one thing we can do here, and this is kind of prelimming what we need next. Okay, unless I'm. Okay, so let me, I guess I forgot. They said A, didn't they? This will give you A. So right here, I wasn't using A, but that is the A value, right? This will give you A. 3, so step 3 is going to be evaluate f prime of A. And what was that A? That was the 1.106 number, right? Now, this should be, okay, if you go into your calculator, remember, the last thing I did is I found that intersection point, right? So whatever you last did on your calculator, that x value is stored in the calculator as x. So if I exit, I hope this works, to my main screen, okay, and I type in, we're trying to evaluate it in the derivative, yes? Derivative is 28 x to the 6th minus 2x plus 1. Okay, notice I put in x's, but it popped out a value for me, yes? It should pop out the same value on your screen. Assuming, did you find the intersection point on the last step?
Well.
Okay, because what it did, so like if I go and do 28 times, what were we, 1.106 to the 6th. I do a second quit to get out of the graphing screen if that's what you're trying to do. Okay. Now, for comparison's sake, I just typed in the equation, used 1.106, which is a rounded version, yes? But do I get about the same answer?
Yeah.
Okay. It's not close enough for AP's sake, Okay, we need a specific, but that's my proof to you that, okay, it really was using that. Okay? Did everyone get their calculators to cooperate there?
Yeah.
Okay, so that is that 50.146773364 is what I'm going to write down. Now, that was kind of taking me to step 3 there, because step 3, actually that was step 3. Why did I? That was that. My steps aren't matching up with their steps, because that really was step 3 there, wasn't it? Okay. We're going into step 4. Use a result in the inverse derivative formula. So G prime of B equals 1 over F inverse of A. Okay, let's think about it this way. We were asked to find what originally? F inverse. Oh my gosh. F inverse prime of, what is it? 3. Okay, our formula says 1 over F prime of F inverse of 3, correct? Basically we're doing this right here, but this is what our inverse derivative formula says. Now, 1 over F prime, what was F inverse of 3? What did that work out to be? That's that 1.106 number, or what we were calling A. Okay? Keep going, because we've already done all the work. F prime of 1.106. Well, that is what?
50.146.
That 50.146773364 number. What do we need to do to finish this off? One divided by, and I'm just going to go up and grab that number. Right? Okay, my calculator says this, 0.01994146. I guess my calculator goes on to say 24 there. Now, okay, AP rules, 3 decimal places. What are the options to give me?
0.020.
0.020. That would be the official rounding version, yes. Or 0.019. Those are your official answers. And I'm confident that that's good because I kept the full decimal all the way throughout. And I know in a way we can say it's a pain to keep the full decimal the full way out, but with the calculator, is it really that bad? No. Okay. And the 3 decimal places is obviously where it's going to matter on the calculator. Okay, so really, I kind of did all of our prep work in steps 1, 2, 3, but step 4 was plugging into the formula, which we'd already done. Okay? And I did just see off on the side notes for step 1. You can graph them and look for the intersection point, which is what we did. There is a solver option.
What?
Let's see real quick. So math, what's that? That looks like that says math B. B. That's not a B. Can I not read my own handwriting?
Barry. Matthew Perry. Barry. Cool.
I'm so confused. What is this B?
Barry.
Well, somewhere there's a solver. Oh.
Beatrice.
Nope. Okay, so in your math menu, that's where it is. So in your math menu, if you go all the way down to the bottom after numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, there's A, B. There must have been an update on my calculator because it's actually C on my calculator now. Numeric solver. Okay? Now, you can enter. And I'm not great at getting this used, but what were we trying to do? We were trying to get 4x to the 7th minus x squared plus x minus 5, right? And what were we trying to get that to equal? 3. And if you hit OK, which is that right there, it will solve it. And notice that 1.106 number is back.
Yes, it is.
Okay. What did you not get? That answer?
This is a hack.
So I'm not great with that. It's something I should probably get better on. Did you type something in wrong? What is 7 minus x squared plus x minus 5 equals 3.
Whoa.
What?
Oh my gosh, that thing would have taken away like literally half of pre-calc and algebra 2.
Like that?
Well, you didn't have these calculators in algebra 2. Okay, why is Aiden's not cooperating?
went to go take that test.
Okay, back out and try again. So I don't know.
What?
The math menu. I don't understand numeric solver.
I can't just walk back then. It doesn't leave.
4x. The 7. Full sleep standing. X plus x minus 5. We move this again on your hand. It'll
Okay.
feel good.
Go back.
How do you make addition there?
We're gonna go back here.
I'm looking at it.
We're gonna go down to B again. I'm gonna do something slightly different. Hit enter. Now I'm gonna hit OK instead.
I have a test to give you. Oops.
I have no idea, which is frustrating.
Yep. No, because I
Okay,
need
I'm gonna clear this out.
I
Just
need to give you 10 words.
4x to the
and
7th
then I need you to do something else.
minus.
As many words.
You did have x squared, right?
I can't.
Plus x minus 5 equals 3.
I'll test you next time. Oh, is it worth it? I think so.
I have no idea.
No.
Everyone else has worked?
Yes.
I'm gonna have to investigate that. I don't know. I do not have an answer for you right now.
Uh-oh.
I don't. That's gonna bug me. I don't know. I'm gonna have to play later. Okay. Okay. Turn in this lesson, derivatives of a few other bases. Okay. These are a few other derivative rules you've got to know. I'll be honest, they're the ones you use the least. Okay. They're not ones that. They're ones that every year I have to relearn. A lot of my derivative rules I know from year to year. These are the ones that every year I have to relearn with you guys and recommit them to memory because they just don't stick with me for whatever reason. But now keep in mind, A is a number. Okay, let A be a positive real number other than 1, and U is a differentiable variable function of X. Okay, key is A is a number, X is a variable. So this is the derivative of what do you do with A to the X? This is not your normal power function, okay? If you see something like 2 to the X and you're asked to take the derivative of it, it's not just moving your X out front and subtracting 1. This is not the power rule, okay? This is the derivative of some other base. So the derivative of A to the X is natural log of A times A to the X. Over here, they use it as A to the U just because this is, okay, what happens when you can take the derivative of what's in the exponent. So it's still going to be natural log of A to the U, but then it's times, this is the chain rule version. Okay, just times the derivative of whatever's in that exponent. And then the other one we're learning today is log. So we know the derivative of natural log, but we don't know log. So this would be like, for instance, if you had log base 2 of x, okay? That would be 1 over natural log of a times x. This version over here is if it's something other than x, where you need to use the chain rule. Okay, so really, the rules you need to know are 1 and 3. 2 and 4 are the same thing, just, okay, if you have a chain rule. So let's practice these rules. Y equals 3 to the x. So differentiate y prime. What is y prime? Natural log of 3 times 3 to the x.
Got it.
Okay. Now, he said it as the rule was written. You could also write it as 3 to the x times natural log of 3. And if you put the 3 to the x out front, you can probably get away without parentheses if you're careful. Easy enough? Okay, it's a rule you have to memorize. B. What about B? It does end up being rule number 2 because we're going to have to employ chain rule. So, derivative of 4 to some power is going to be what? Natural log of 4 times
4 2.
Don't think hard. Yep, just it stays as is, 4 to the 3x. So that's the derivative of a to some power. But then what about the power in this case?
Oh,
Is there a derivative of 3x?
yeah.
Yeah, what is the derivative of
3.
3x is 3. Okay.
Fan of the number 3.
No. I looked down at my notes too late. And I'm not a fan of the way they did this problem and what we didn't do. Okay, so I can write this as 3 natural log of 4 times 4 to the 3x. I'm not a fan of what they did with this problem, but here's what we can make it work from our piece. This is an equivalent answer, okay? What they did up here is they, instead of making this 4 to the 3x, they went with 4 is the same as 2 to the second raised to the 3x, which means then they did 2 to the 6x is what they did the derivative of. Now, it's how your answer looks in this end. Now, here's the deal. We can get both of these things. First of all, what do you know about 4? 4 is 2 to the second, yes? Well, what do you remember about when there's a power on a log? Where can it go?
Front.
It can go out front. And what do you know about 2 times 3? So this can be 6 times the natural log of 2 times, and then the other thing they can actually do, 4 to the 3x. You can go ahead and do the 4 to the third and just leave the x there. So 4 to the third, 4 times 4 is 16 times another 4 is 64 to the x. Now, all of that to say is there's a lot of different ways you could leave this answer, which only matters when it comes to multiple choice and, you know, because now if you go and do this one here, like if you do this derivative here, what do I want to say here? 2 to the 6x. So if we use the rule then, it's natural log of 2 times 2 to the 6x times the derivative of 6x, which is 6. Well, notice all those pieces match. Once 2 to the 6th, guess what 2 to the 6th is? That's 64. Okay. Yeah, I kind of forgot. There's a whole bunch of different, different ways to get there. It's not a matter of right or wrong. It's a matter of what you see. Okay. Okay. And that one just became complicated because of the base of 4. C. Okay, C is more basic. Y is 5 to the x squared power. Y prime. Natural log of 5 times
X squared 2x.
about, keep it at, follow your rule right here, a to the x or a to the u, so just the original problem, 5 to the x squared. So it's natural log of the base, so natural log of 5, then times the original problem, 5 to the x squared, and times the derivative of the exponent, which is the 2x. Okay? That one, that answer is really about as good as it gets. Yeah, you could rewrite it a couple of ways, but you could also leave it as is. Okay? D.
Oh boy.
5 to the 3 minus x squared. Natural log of 5 times 5 to the 3 minus x squared, because it's natural log of the base, times the original problem, times
Negative 2x.
derivative of the exponent, chain rule. So negative 2x. I don't know, I guess if you wanted, I have it underlined like that in mine. If you wanted to say negative 2x, natural log of 5, times 5 to the 3 minus x squared. There's no ideal, It's hard to, there's no best way to write that. Okay? So those are practicing your exponent, that's exponential, derivative of an exponential. Now let's go practice derivative of a log. Remember, derivative of a log, 1 over natural log of the base times x, so times the inside. So y equals log base 5 of x. Yeah, open and full. Y prime.
What's the difference between the x and the u?
U is just, then they have the du dx showing chain rule.
So du dx means chain.
Yeah, it just means you're doing the derivative of whatever u is.
What about du dx just means derivative?
It's a derivative of u with respect to x, is what du dx is. Okay, so what are we going to have here? It's supposed to be 1 over natural log of the base. So 1 over natural log of 5 times the insides, which is x. And be careful, that is not to be confused with the natural log of 5x, right? So in this one, it is probably better to say 1 over x times natural log of 5. Okay? What about B? Log base 3 of sine of x. 1 over
log of 3.
Natural log of the base, so natural log of 3 times, it was the insides, which is sine x. Now, what do you know about sine x? There's a derivative to sine x, isn't there? Unless it's just x, you gotta take the derivative. What's times the derivative of sine x, which is? Now, that cosine x is not going in the denominator. It is times just the whole expression. Okay? Which means if it's not going in the denominator and it's multiplying by that fraction, it can also be thought of as on top. Okay? So when you do that chain rule, what you're multiplying by for that chain rule goes outside. It's not like wherever you're at. Okay? We could leave it as this technically. Cosine x over natural log of 3 times sine x. Or, let's talk about some other options.
Cotangent x over
Cotangent x over natural log of 3, because cosine over sine is cotangent. I have one other or. What's the reciprocal of cotangent?
Secant tangent.
No, not derivative. The reciprocal of cotangent is tangent. So if you take that cotangent to the bottom, it could be 1 over tangent x times the natural log of 3. Again, it's not right versus wrong here. It's options. Okay? Is there anything wrong with the first one? No, there's not. Okay, C. Y equals log of x plus 3 to the x. Okay. Are you guys with them on the 1 over natural log of 10? What's the invisible base when no base is listed? 10. So 1 over natural log of 10 times x plus 3 to the x. Okay? That's your initial derivative rule, yes? But now we've got to say times the derivative of x plus 3 to the x. What's the derivative of x? 1. Plus, what's the derivative of 3 to the x? Natural log of 3 times 3 to the x. That's the rule we just learned, isn't it? There's not a whole lot of cleanup to do here, but the cleanup that probably should be done is making this into one fraction. Because that piece at the right, when you multiply it by this fraction, can go on top. So I can say 1 plus 3 to the x, natural log of 3, all divided by natural log of 10 times x plus 3 to the x. I just realized that x plus 3 to the x should have been in parentheses the whole time. Okay. D looks fun, doesn't it?
No, really?
Now, do we need a basic rewrite for a moment? This is also what? Log base 2 of 2x plus 1 to the what power? 1/3 power. Okay. Y prime. What's my log rule here?
1 over natural log of 2 times cube root of 2x.
Okay. 1 over natural log of 2 times the cube root of 2x plus 1. And you could write it as a 2x plus 1 to the 1/3. I might have to later, but I don't right now. times now you're basically doing the derivative of that cube root.
1/3 2
Times 2.
No.
Oh, wait.
I'll do it times 2 eventually.
Times.
What happens, this is, think of, if we're just doing the derivative of this piece, this is a power rule.
1/3 times 2.
1/3 times 2x plus 1 to the what power?
-2.
Negative 2/3. And then times the derivative of the inside, the derivative of 2x plus 1 is 2.
This is bad.
We were chaining.
This is like calculus 2. What?
No, it's not Calc 2. It's Calc 1. Okay, did you guys follow that? So the derivative, so we had to do the chain rule and do the derivative of the cube root. Well, a cube root is a power of 1/3. So move the power out front, keep the inside the same, subtract 1 from the power. Then if your inside is basically anything other than x, you have to take the derivative of the inside. Derivative of 2x plus 1 is 2. Okay? Now, there is a little bit of cleanup we could do. Let's see. The 2 can go on top. I think everything else is going to go on bottom because 1/3, that 3 goes on the bottom, and this negative 2/3 power can go on the bottom as well. So I'm going to put the 3 from the 1/3, the natural log of 2 out front. Then I'm going to write this cube root, the 2x plus 1 to the 1/3. And then when I bring this negative 2/3 down, I have 2x plus 1 to the 2/3. What about 2x plus 1 to the 1/3 and 2x plus 1 to the 2/3?
2x plus 1 to the 3/3 or 1.
Yes, because you keep the base the same when you're multiplying, and you add the exponents. 1/3 and 2/3 is 1. So I'm going to write this as 2 over 3 natural log of 2 times 2x plus 1. Okay. Go ahead and look at 8. I don't know if we'll quite get through 8 or not. Maybe, maybe not. No, it's not. That's the unfortunate part. Now, I will say some of that stuff on the last page, I think you'd be okay on with the chart. So that's fine. But, okay. 8. Find an equation of the tangent line of f of x equals 6 to the x, where x equals 2. You know how to do this part. Equation of the tangent line. What do you need to write an equation of the tangent line?
Slope.
You need a derivative, aka slope, and you need a point. Okay, so the derivative. F of x equals 6 to the x, so what's the derivative of 6 to the x?
Natural log of 6
Natural log of 6 times 6 to the x. Yes? We need to know that derivative evaluated at 2. So natural log of 6 times 6 to the second. Or, what does that clean up to be? I'm going to write it as 36 natural log of 6. I have a decimal here. Why do I have a decimal here? I have a decimal here also. If you put it into the calculator, you could get it as 64.5033408. I don't know that you need the decimal. I would be fine with that. We also need what else besides, this is my what? This is my slope. We also need a point. How do we get our point? Yeah, we find f of 2, which is 6 to the second, so f of 2 is 36. So we have the ordered pair, 236. So we have our x and our y, and we have our slope. Can you write an equation of the tangent line? Yeah. Y equals, I'm going to use 36 natural log of 6 times x minus 2 plus 36. Okay? Okay. What do I want to do? So we haven't gotten 9 in the back page. The back page is tables. And we did a little bit with tables at the beginning. I'm going to go ahead and say try homework. I think the stuff you need, we've done, I think. That's what I'm trying to check. Number 9 might have been a key problem we didn't get to. But, so go ahead, try the homework. We'll figure out tomorrow when we get in here if we need to finish any notes or if we can just do homework questions and move to 3-5. So go ahead and attempt the homework and see where you get with it, okay? Okay. And it's 12:33.